All right. So welcome back to SAS Bootcamp. This is week 6's homework video and Q&A. So for those of you that have been around for 6 weeks, I appreciate you all hanging around and working through the homeworks this far. If you've made it this far, hopefully you've learned enough in SAS to do your own research right after this one. So for the rest of today's video, what I want to do is go over Q&A. I want to talk about the homework for this week and talk about answers. I also want to hear from the people on the call right now to see what they may have done differently from what I am going to show on my screen. And we can talk about easy pitfalls and differences in programming styles and differences in approaches when programming for a health outcomes project. And I also want to give a brief preview for next week. Right. So let me begin with that in the backwards order. First, let me talk about next week. So next week, we don't have any new content to be shared. This is the last week of content for this bootcamp. But having said that, there is an exception to that. Next week, I will be uploading one video where I want to talk about programming etiquette, right? When you are programming in SAS, there are several good practices that you have to follow. Most of what I've been teaching for the past 6 weeks have not taught anything about good programming practices. And I think the first thing that you need to learn right now before you become comfortable with SAS is getting some of those good habits inculcated into your programming practice. And if you do that, I think programming behavior gets better. And if you learn some easy shortcuts now, it will be very difficult to correct them later on. So I want to get those good programming practices inculcated in you as early as I can. So next week I will share that video. And then I'm going to give you all some space. I am not going to share any other videos next week about new content. There is, of course, a lot more to learn in SAS. If you have hung around for these 6 weeks, you've learned hopefully a good bit, but you've not learned even a tenth of all the things you can learn in the universe of SAS and in the universe of health outcomes programming, because this is merely an introductory bootcamp. But I'm not going to add any more new content next week. We are going to talk about good programming practices, and then I'm going to give you guys some time to work through the class project. I'm considering uploading the videos for how to solve the class project next week on Friday, but I'm beginning to think that given only 3 people are on this call right now, we could use having a little more time. So I might delay those videos by 1 more week. So I will communicate over email. I want to hear from you guys as to how you are making progress on your class project. And if you want to take 1 more week to work through that project, we can work through the solution for the class project, not the coming Friday, but the Friday after that. So let's have that discussion offline over email or other online sources. And then we can decide if we want to share the class project information next week or the week after. But this really concludes all of the content for the SAS Bootcamp. This is the last video for the content within the bootcamp itself. This week, I have actually not received any questions about the videos and the content at all. I have received 4 or 5 people reaching out to me about the answers they've gotten, about the homework specifically, but I've gotten no questions about the content. I'm assuming that is because the content this week was easy and it was hopefully relatively straightforward. But if somebody has any questions, please let me know. For those of you on the call right now, did you have any questions or concerns about the videos that I shared this week? Okay, I'm not hearing anything. I'm assuming that means you guys don't have any questions. And really, especially some of the statistics parts I've covered were pretty simple. And Hang, like you mentioned, I know the macros were challenging. So if you have questions about macros, let me know. Okay, not hearing anything. I want to switch gears quickly and talk about the homework. I've uploaded the homework file to the SAS Bootcamp. So you should have it on SAS Studio. Let's go ahead and talk about how I have approached this problem and how I obtained the answers that I did obtain. And then I want to hear from you guys on the call after that to talk about how you may have approached this issue. So if you remember the homework basically said you have to identify difference in healthcare costs between individuals, between males and females, and it has some eligibility criteria towards those research questions. The eligibility criteria was that individuals had to be eligible for the 7 months for which data were provided in the patient_info file. The other eligibility criteria was that individuals had to have diabetes. And having diabetes is basically identified through the hospital claims file, where in the Benny_visit file, which is what the file is called, if they have the word diabetes in a diagnosis field at least one time across all of their hospital visits, that means they have diabetes. So those are the two eligibility criteria. And then you have to pull the outcome variable, which is healthcare costs, which come both from the prescription drug file and the hospital use file. And you have to add both of those costs and then identify total healthcare costs for individuals in the eligible population, and then compare across males and females. So let me go ahead and talk about how I've done the eligibility check. Some of these things we've done in other homeworks before or other exercises before during the past few weeks. So some steps should be familiar and straightforward, but really the challenge in this homework is stringing all of those things that you already learned together into one cohesive project. That, I think, is the biggest challenge for this homework. And it's also the place where you're most likely to make errors that are not syntactical errors, but are logic errors or programming flow errors. So let's talk about how I've approached this, and then we can go and discuss a little about how else you can approach a problem like this. The first thing I want to do is do the eligibility check. So I'm using my patient_info file, which let me open that up really quickly. So the patient info file has 7 variables that talk about eligibility, and those are the 7 variables shown on screen right now. We want to make sure an individual is eligible for all 7 columns or all 7 months of data, which means the sum of the 7 variables has to be equal to 7. So here I've literally just said eligibility equals sum of, and I've listed the 7 variables with a little hyphen in here. I've then deleted any individual that has this variable equal to less than 7. And I've done that using my implicit statement. I've said if eligibility equals 7, semicolon. I could have, if I wanted to be explicit, I can write then output, and that will do the same thing, but it's a little more explicit. And then I want to use my drop statement because I don't want any of the variables that I'm not interested in. I'm going to keep my data set as small as possible. So here's my log. Log looks okay. Output, you see we went from 18 people down to 16 people, and all 16 people are eligible for all 7 months of the data set. Next, we want to make sure we check the second eligibility criteria, which is making sure that individuals have diabetes. So let me pull up the hospital claims file, which is the Benny_visit file. And I want to talk about one important nuance in this data set that I think some of you may have missed. So let's look at this file. Right? This file is an event level file. So every time an individual goes to the hospital for an event, for a hospitalization event, that's one row in the data set. This is typically how administrative claims data are set up. It's not necessarily always the case, but it's typically the case. Well, in this case, if you have 3 different rows for Benny ID 1, that means beneficiary was admitted to the hospital 3 different times. And here are all of the diagnoses that were identified for these individuals in the hospital, right? One important thing to observe here is that this individual has diabetes in the first visit, they don't have diabetes in the second visit, and they have diabetes in the third visit, right? So that's a very interesting nuance here. The fact that they have diabetes in visit 1 and visit 3, but not visit 2, should tell you that this individual is actually a diabetes patient, but on that second hospitalization, diabetes was not listed as a disease because the doctor that was treating that patient did not think that that particular hospitalization was related to their diabetes. Maybe on 13th of August 2010, they were admitted to the hospital because of sickle cell anemia problems or because of hypertension problems, but not because their diabetes had a problem. But on 26 February or 24 December, they did have a diabetes problem. What this means is that even though a particular row of data for this individual may not have diabetes, this individual actually does have diabetes. It's just that that information was not presented in that particular row. So what's important to recognize when you are doing the second eligibility criteria is you want to look for diabetes at a patient level, not at a hospital visit level. Okay, and that's a very, very crucial and important difference that can throw your results off. So what I've done here is, first thing I've done, I want to pull all of the claims here that are for our eligible individuals. So I know that there are some individuals, there are two individuals specifically speaking, that don't have 7 months of eligibility. I am not interested in hospital claims for those two individuals. The way I delete those hospital claims is by simply using a left join. Okay, I will take my data set that was created here, elig_info. I will write that in my left join with my hospital file, which is my Benny_visit file. I'm selecting all of the variables from both data sets, saving them in a file called elig_claims, and I'm doing a merge on the Benny ID. So because this is a left join, only rows from the Benny visit file which have the same beneficiary that's present in the elig_info file will actually get added into my final data set. Individuals that are present in the right side file, the Benny visit file, but not in the left side file, the elig_info file, will not get added, which is exactly what I'm looking for. Individuals that are not eligible, I don't want their claims. So let me go ahead and run that. Check my log. Log looks okay. It is giving me a warning that Benny ID already exists. The reason it's giving me that warning is because I did a.asterisk and b.asterisk, and actually asterisk means all variables, but the Benny ID variable is in both files. So it's telling me that Benny ID already exists, which does not bother me. I know it already exists. That warning does not affect the validity of my final result. So here is what my output looks like. You will see that my output now has 51 rows because the Benny visit file has 53 rows. And if you take out the two individuals that were not eligible, apparently they had 2 claims or 2 rows of data, which ends up with 51 rows in our final file. Next, I want to take this data set, which has 51 rows and which is all the hospital visits for my eligible population, and check to see if diabetes was present or not in each row of data. So to do that, I'm just going to write a data step. I don't have to use a proc SQL every single time, right? So I'm going to go back to a data step here. I'm going to create a file called diab, diabetes, from my elig_claims file. I'm using an array statement to do this. I have 10 different diagnosis variables. I could have written 10 different if-then statements, but that seemed laborious and unnecessarily long. I want to keep it brief. So I'm going to write an array statement. I'm calling my array dx. There are 10 variables in my array, and those variables are called dx1 hyphen dx10. So it's all 10 of those variables from 1 through 10. I'm then setting a flag variable that I'm calling diab equals 0. And I'm going to change that flag variable to 1 if I identify that that row of data has the diabetes diagnosis in it. I'm using my array within a do end loop with I as my counter variable. So do I equals 1 through 10. I'm using 1 through 10 because there are 10 variables in my diagnosis array. And I only have one statement within my do loop. It says if dxi, and this dxi is the format for referencing an array. The dx array is being referenced at the ith position. The position I, which goes from 1 to 10, is being referenced here. And it is the condition is saying if dxi equals diabetes, which you'll see here, the word it is spelled exactly diabetes. Because I know that it is spelled with a capital D, diabetes, I'm just writing that. If I wanted to be careful, I could have used a lowercase function and used a lowercase d here, for example. I could have used the contains operator. I could have done some other things. But because there are only 51 rows, I can just scroll across from the top row to the bottom row. I know exactly what the diabetes variable looks like, the diabetes value looks like. So I just wrote it as it is. If you are doing a real project, I would encourage you to be a little more careful in if statements like these. But now that I know what the data looks like, I'm comfortable with this. So if condition, then I'm changing my flag variable from 0 to a 1. And I have my end statement. I'm dropping the variables I'm not interested in. So I'm not interested in holding on to the I variable. I'm not interested in my 10 diagnosis fields because I now have a variable called diab that tells me if they have diabetes or not in that row of data. I'm not interested in the visit date. I'm also not interested in the cost variable. Some of you may have held on to the cost variable at this stage, but really I don't think it is necessary. We can come back to calculate cost later. The other thing that I am not doing in this data step, and this is important, is that I am actually not deleting any rows which don't have diabetes equals 0. So one thing you may have done as you're doing this is you may have written an if statement saying if diab equals 0, then delete those rows. I am not deleting those rows right now. I'm going to hold on to them, and I will work through that step later in the code. Let me check my log first. Okay, log looks okay. Here is my output data set. you'll see here that my DIAB variable has a bunch of zeros and ones. So for example, for individual 1, they had DIAB equals 1 twice, but they had DIAB equals 0 once, right? So do not confuse this. Do not confuse the meaning of this variable. This variable, the only thing it is telling you is if they had a diabetes claim in that row of data. It does not tell you anything about whether that individual has diabetes or not. In order to know if that individual has diabetes, you need to sum across rows and identify and create a Benny level file, which will tell you if they have diabetes or not. At this row of data, you only know if the row itself has a diabetes claim or not. Okay. So individual 1 who has DIAB, who actually has diabetes on 2 of their claims, but not the third one, they have diab 1 and 1 on 2 claims, 0 on the other one. But this individual actually does have diabetes, right? So let's go from a claim level file or an event level file to a beneficiary or an individual level file. To do that, I have to do reading across rows. And if you want to read across rows, you need to use first dot and last dot variables with the retain command, or you need to use proc SQL with the group by step. I prefer using the proc SQL with the group by step. You are welcome to use a different step if you are comfortable using data steps and retain statements and first dot and last dot variables. You're welcome to do that. So what I've done is I've taken my DIAB file, I've set it in my from statement and created a new variable called ELIG_PT. I'm calling this ELIG_PT because this really is my data set of eligible patients. Because remember, this data set that we had just created is all the people that have eligibility. Eligibility equals 7. Our next data set should be the eligibility equals 7 and they have diabetes, right? So this is my eligible patient file. So I'm calling this ELIG_PT. Let's come back to the select distinct statement. I have a group by statement where we are grouping by Benny ID, because remember, we have to go from an event level file to an individual level file. So our grouping variable, our bucket variable, is the Benny ID variable, which is individual patient. So group by goes into, group by says Benny ID. And then in my select statement, I'm adding distinct because I'm just following good coding practices. And then I have my first variable in my select statement, the same variable as my group by statement. So my grouping variable Benny ID is my first variable in the select statement. Every other variable I have in my select statement is a summary variable, every single one. Even though I don't have to use summary variables on some of these, summary functions on some of these variables, I go ahead and use summary functions anyway, just to make sure I am following good coding practices. So for example, I'm saying max of gender should be saved in a variable called gender. I don't have to do that, right? Gender does not change within each bucket, within each group, which is within each individual. Gender is actually constant. So I don't have to use a max function in order to bring the gender variable up to the Benny level. Gender is already a Benny level variable, but I'm using the max variable anyway here in order to follow good coding practices. If I don't use the max variable, and if I have imperfections in my previous merge, or maybe I have some missing values or some other imperfections in the data set, that can throw off the group by statement. And I want to be careful to not do that. Even though in this particular case with 51 rows, I know there are no imperfections, but when you're working on a data set with hundreds of thousands of rows, those imperfections are pretty common. So I want to use this summary function max in the gender variable in order to make sure I account for those mistakes. And I do the same thing. I summarize my race variable, which shouldn't need summarization, but I'm going to do that anyway. I also summarize my date of birth variable and my ELIG variable. Again, those variables do not need summarization. I'm doing that as good coding practice. And finally, the one variable that I do need to summarize, my most important variable, is the DIAB flag, which we used earlier. This flag was equal to 0 on claims where diabetes was not identified, and it was equal to 1 on claims where diabetes was identified. When grouping by Benny ID, I want to use the max function because I want to say that if an individual has diabetes on even one claim out of the 10 times they went to the hospital, if they had diabetes on one claim, then they actually do have diabetes, right? So we want to make sure we identify somebody as having diabetes if they have diabetes even once on one hospitalization. So I want to use the max function, which basically says if you identify zeros and ones in the diabetes variable within one group of beneficiary, then make that final variable be the max of 0 and 1, which is equal to 1, and save that in a value in a variable called DIAB. So we are using the max summary function and the DIAB variable in order to make sure we capture every single individual that may have been identified with diabetes just even once out of all of their hospital visit rows. So that's what this code is doing so far. On top of this, I have the having statement included here. You may not have used the having statement. In fact, so far out of all of the 6 weeks, I have not shown you guys how to use the having statement. I remember I may have included a comment in my ProcSQL code in week 5 where I said, you can go look up the having statement if you want to use it at a later date. What the having statement is doing here is actually the same exact thing as a where statement. If you remember a ProcSQL, the where statement says basically only hold on to those rows where a certain condition is met. The having statement does the same exact thing as where, but the reason why I have to use having instead of where here is because the condition in my having statement uses a variable that is a part of a summary function. Okay? Because I am creating a new variable DIAB, even though it has the same name as the old variable, this new variable is the variable that is being input into my having statement. Because of that reason, I have to use having, not where. Right? If I were using a variable that's not a part of a summary function, a variable that's not being created in the select distinct statement, I can use a where statement and it would have worked just fine. But because it is being created as a new variable in this statement, I have to use having instead of where, but really it does the same exact thing. The having function or the having statement makes sure that the final data set only includes those individuals where diabetes equals 1. If you are not comfortable using having, you can just take this part out. You can finish your ProcSQL here, and then you can write a simple data step where you delete individuals where DIAB equals 0. Or you only hold on to individuals where DIAB equals 1. I wanted to be a little more efficient, and I wanted to use this opportunity to show you guys what a having statement does in ProcSQL. So I've gone ahead and used this here. If anybody has questions, please interrupt me. I would rather pause now and explain what I'm doing than come back to it later. Okay, so now after my ProcSQL with the group by statement, I have only 14 rows of data because remember we had 16 earlier, but 2 of those 16 people did not have diabetes. So now I have 14 rows of data and you can see my DIAB variable, which is now the summary function, the max variable. It is equal to 1 for all of my 14 individuals. So this data set with 14 individuals have full eligibility for 7 months and have diabetes for every single one of them. This is my file of eligible patients, right? Now, once I've done eligibility and I've completed it, now I can move on to outcomes, right? The outcomes we are interested in for this homework are the cost variable. Cost variable, when pulling cost variable, you have to remember certain things. Healthcare costs have to be calculated for every individual regardless of whether the particular row of data was for a diabetes related healthcare utilization or it was not. Because sometimes diabetes patients may go to the hospital or fill medications for other diseases, say hypertension or sickle cell anemia, but those costs are still included in their healthcare costs, whether or not those particular medications were used for the treatment of diabetes. So do not try, when you are trying to calculate healthcare costs, do not attempt to separate costs that are because of diabetes versus costs that are not because of diabetes. This method of calculating of costs is called all costs healthcare costs. And I don't want to get too much into the study design and theory and operationalization of healthcare costs, but just take my word for it that when we are calculating costs, especially for this homework, we want costs attributed to any healthcare utilization, not just diabetes related healthcare utilization. The way I'm doing healthcare costs from my prescription file, we have to do it for both, for the prescription file and the hospitalization file. Let me first do the prescription file. If I want to identify prescription file related costs, let me first open the RX claims file. This file tells you every single individual's prescriptions, and it actually gives you a fill date, a day supply, and an NDC code. This is good. We can identify prescriptions for our eligible beneficiaries, but this data set does not have the cost information, right? The cost information is in another data set called NDC_FAD690, which gives you the NDC code along with AWP, right? So first thing we need to do is we need to add cost to this data set. And we are going to do that by looking in this NDC_FAD690 data set and pulling the AWP variable into my RX claims data set. And I can do that merge based on my NDC code variable. My NDC code variable is common in both the NDC underscore FAD 690 dataset and in my RX claims dataset. So I have written a little bit of proc SQL code to basically merge my RX claims file with the NDC file and bring my cost variable into the RX claims file. So you'll see here I'm creating a new variable called RX, new dataset called RX underscore cost. I'm doing so from RX claims on the left as A. I'm using left join. I've told you this before. I prefer to use left join almost every single time I do a join, just because it helps me think through the process clearly and avoid errors. On the right side, I'm using my FAD underscore 690 file as B. In my select statement, I want every single variable from my left dataset, which is RX claims, and on my right, from my right dataset, which is the B or the NDC dataset, I only want one variable, which is AWP, which is average wholesale price or the cost. I am not interested in any other variables on the right side. In fact, you will have recognized that the RX claims file has 82 rows, but the NDC file has 15,000 rows, right? Because only 82 prescriptions were filled, but the NDC file has a list of every single prescription available in the pharmacy. We don't want every one of those prescriptions. We only care about the 82 prescriptions and the 82 NDC codes listed in the RX claims file, which explains why we are doing a left join. Doing a left join here means that my final data set will include all of the RX NDCs that are in my RX claims file and not include any NDCs that are in the right side file, but not in the left side file, right? That's the definition of left join. So we are going to do a left join based on the variable NDC code. So I've written on A underscore NDC code equals B underscore NDC code. The variable has the same name in both data sets. In addition to doing this, I'm actually including a where statement. Now, I did not need to include this where statement here. Again, this is me trying to show the efficiency of proc SQL. You could have done this in 2 different steps if you would have preferred to. I like doing it in one step because I think it makes my programming more efficient. What this where statement is accomplishing is that it is taking my previous select from and on statements, which is the merger of the RX claims with the FAD 690 dataset. It's going to take that whole dataset, and then it's only going to hold on to those rows where this condition is met. What's the condition? The condition basically says a.bennyid, which is individuals in the RX claims file, will only be retained into the RX costs files when they are the same individuals that are present in the Benny ID from the elig underscore patient file. Remember, the ELIG underscore PT file gives you the data set of all the eligible beneficiaries that we are interested in doing the analysis for. This where statement makes sure that anybody that is not eligible, because remember, we had 18 people in the original data set, but only 14 of those 18 are eligible. So this where statement will make sure that only the prescription claims from those 14 eligible patients are retained in my RX cost file. Right? This is the strength of the proc SQL. We are basically merging 2 data sets right now using a left join, and we are subsetting that merged data set based on the values of Benny ID in a 3rd data set. Okay? So we are only holding on to prescription claims for individuals that are eligible, and we are adding the cost variable from the NDC dataset at the same exact time. All of that is happening at once within this proc SQL set. I'll check my log here. Log looks good. Check my output. My output, while including 80 different rows, actually only includes data for 14 eligible beneficiaries. Okay. The other 4 non-eligible beneficiaries have been deleted from this data set. And I also have a really neat cost column here called AWP. Other ways you could have approached this include, for example, you could have done this merge in a data step. You could have used the merge statement. You don't have to do a proc SQL left join to do the merge. And at the same time, you don't need to do this where statement right here. In fact, you could have done this many different ways. You could have written, after doing the merge with the data step, you could have written another merge statement where you merge it with the ELIG underscore patient file and then do a left join to delete the claims from prescriptions of individuals that are not eligible. Or you could have not done that there and you could have done it much later. So really, there are many ways to approach this problem. I am doing it this way because I find it efficient and I find it easy to conceptualize in my mind as I logically think through this program and what I need to do. Okay, so now my RX file, RX underscore cost dataset includes prescription claims for all eligible individuals and the costs related to those prescription claims. Next, I need to identify Rx costs, not just Rx claims. To do that, I have to read across rows. So I'm going to use a proc SQL statement again because we need a group by statement. Here we are grouping by Benny ID because we need cost at an individual level, not a prescription level. So I'm creating a new data set called PT underscore Rx cost. I've used PT as a prefix to help me remember that this data set is at a patient level, not a prescription level. In my from statement, I have Rx underscore cost. In my select statement, I have my grouping variable Benny ID, and I only have one other variable, right? I only have one other variable because all of my other variables in this data set, fill date, day supply, NDC code, I don't care about those variables anymore. The only thing I'm interested in is the cost variable. And I'm using the sum function because I want to sum across AWP variable within each group or bucket, which is the individual in this case. So I'm using the sum AWP and I'm saving that in a new variable called Rx underscore cost. So what this will do is it will take, let me start this. So it will take these 5 prescription claims for individual one, and it will add all of these rows of prescription costs. It will add these 5 rows, excuse me, and save that into one variable called Rx cost, and it will only include one row of data for each individual in my data set. So let me hit run. Check my log. Okay. So now we have Benny ID and Rx cost. That's it. We have one row for every individual, and this one row presents all of the costs for all of their prescriptions from the earlier file. The interesting thing you will observe in this data set is that we only have 11 rows. Now, if you remember from our ELIG underscore PT data set, there were actually 14 individuals that were eligible. Unfortunately, 3 of those individuals do not have any prescriptions whatsoever. So for those 3 individuals, we should associate an Rx cost of $0 for them. But instead, we are not going to do anything right now. We are going to hold on to 11 different rows, and we will assign that 0 number to those 3 people, the 3 eligible individuals that don't have prescriptions, at a later point in the code. Again, you could have approached this differently, and that's acceptable. So that gives us prescription costs. Next, let's talk about hospitalization costs. Again, you can have done hospitalization costs any number of ways. What I am doing here is I'm using the Benny visit file. So I'm going back to the original Benny visit file, and I want to calculate this cost column for each individual, whether or not each row of data has the diabetes claim in it. Some people that I know have shared their code with me leading up to this class have approached this differently. What they've done is they've actually deleted every row of data that does not have a diabetes claim and then calculated costs. That is incorrect, because if you do that, you are basically deleting for individual one, you are deleting row 2 where diabetes was not listed, but that $1,400 for this individual are actually valid costs that they had to pay. So when we calculate healthcare costs for individual one, you have to include that $1,400 in addition to the $314 and the $585. Right? So if you delete rows of these data where diabetes was not present before calculating costs, then you will have the incorrect answer. So when we did the diabetes identification earlier in the flag diabetes claims piece of code here, we actually did not delete any rows. And in fact, I am going back to the original Benny underscore visit file to calculate my costs. I am not using my DIAB file. I'm not using my ELIG PT file. I'm going back to the original Benny underscore visit file to calculate hospitalization costs. So here it is in my from statement of this proc SQL. I'm saying class.Benny visit is my from statement. And in this data set, in this proc SQL step, my goal is to identify total hospitalization costs. When you hear total hospitalization costs per individual, you have to think reading across rows. So I need to do this with a group by statement within proc SQL. So here is my group by statement. My grouping variable is Benny ID because I want to identify costs for each individual in my data set, each individual. So group by Benny ID. So in my select statement, I have select distinct, Benny ID, which is my grouping variable, followed by my summary variable, which is sum of the cost variable, right? So it's just going to take this cost variable, it's going to sum across the 3 rows of individual one, and it's going to save that in a new variable called HOSP underscore cost. So we are taking all of the costs from all hospital visits of each individual and saving that in a new variable called HOSP underscore cost. Now that should be what I need, but remember, I still need to subset my data set, and only have the individuals that are actually eligible. There are multiple ways I can do this part as well. What I've chosen to do is I've chosen to include a where statement here. I am including a where statement to subset my data set, my Benny underscore visit data set, so that I can delete all the individuals that are basically not eligible for my final file. The way I'm doing that is in my where statement, I've said where Benny ID, which is the variable that's in here in the select statement, that variable should be present in, and I've used the in command to say that, it should be present in the variable Benny ID from the file elig underscore pt. This basically makes sure that the only individuals in this data set, in the pt underscore hosp underscore cost data set, are individuals that are eligible for my study. You could have approached this eligibility issue with cost any number of ways, right? You could have just skipped this where statement here, run the rest of the proc SQL with the group by, calculated cost for everybody, and then deleted individuals that are not eligible. You could have done that. Or you could have calculated cost for everybody and then use the left merge with my eligibility file, and that would have deleted individuals that are not eligible. So you could have approached this problem any number of ways. I have approached it using this particular approach for a good reason though. The reason I've done this is because if I am subsetting my data set within this proc SQL step directly, what I'm doing is I am creating a patient underscore HOSP underscore cost file, which actually has unnecessary data removed from my data set. And removing that unnecessary data can be important if you're dealing with data sets that are several gigabytes in size and you're worried about processing speed, processing time, how much memory you have on your computer, so on and so forth. So by doing it this way, I'm making sure my programming is more efficient. And it's something you have to think about if you're working with large data sets. If you're working with smaller data sets, you could have done the where statement somewhere else and it really would not have made a difference. Okay. Long spiel for that proc SQL, but I hope that was clear. Let me check my log statement here. We have 14 rows, which is good because remember our eligibility file had 14 individuals. This tells me all 14 of those individuals had hospitalization costs. And here you see the numbers. So individual 1's hospitalization cost was 2301. For individual 3, it was 4416, and so on and so forth. Okay. So now what have I done? Let's recap. We've identified eligibility based on enrollment and diabetes. Then we've identified prescription costs, RX costs, and we've identified hospitalization costs or HOSP costs. Next, we need to basically put these three data sets together, calculate total costs, and we'll be ready to do our analysis. So if I want to put three data sets together, I'm basically merging data sets. I could have done this in a data step, but you know that I prefer using proc SQLs for merging. So I have another proc SQL statement written next. In this proc SQL statement, I have in my from data set, I'm creating a data set called all costs. In my from statement, I have my eligibility file, elig underscore pt. I'm adding the nickname A to it, the shortcut way of referring to it as A. I'm using the left join to merge that with my prescription costs file at the beneficiary level. And I'm using left join to make sure that if there are any individuals left over in this data set that are not eligible, they get deleted. And the only individuals left in my final data set should be the individuals that are in the elig underscore pt file, which means they are the eligible patients. Okay, so I'm doing the merge with these two data sets using a left join on the variable Benny ID, a.Benny ID equals b.Benny ID. And then the output of that merge is then being merged with the patient hospital cost file, which we have just created with 14 rows. And that I'm labeling as C, and I'm doing that merge also using a left join on a.Benny ID equals c.Benny ID. My select statement has only the variables I need. My eligibility file, for example, had several extra variables like race, date of birth, ELIG, DIAB. I don't need any of those variables right now. The only things I need to know at this point are, I need to know the individual's Benny ID, I need to know their gender and their cost. So Benny ID, a.gender, b.rx cost, c.hosp cost. I don't care about any other variables. And by dropping additional variables, I'm keeping my data set size manageable and I'm making my programming and processing more efficient. Okay, so here's my final file. You'll see that we have 14 rows because we had 14 eligible people. Here is the gender for each of those 14 people, prescription cost, hospitalization cost. Interestingly, 3 people have missing values for gender. They have missing values for gender because remember when we calculated the RX cost file, there were only 11 individuals in that file. And that happened because 3 people did not have any prescriptions and they did not have any prescription costs. So when we did the left merge, it basically labeled them with missing values for the RX cost file. And it only did that because in my left join, I used my eligibility underscore patient file on the left side and my patient underscore RX cost on the right side. If I had flipped it, it would have actually deleted those 3 people from my data set. And I don't want that. I want them to be in my data set because they are eligible. They just did not have any prescriptions or prescription related costs. Okay, so here is what my output data set looks like. My total cost variable now is basically the sum of this plus this, this plus this, so on and so forth. And if somebody is missing on the RX cost file, I want that to be considered as a 0, and I want their total cost to be equal to their hospital cost. That calculation, I actually could have done that within my ProcSQL, but doing too many things in ProcSQL is not really helpful. So I'm actually going to do that in a separate data step where it is much easier to understand, much easier to debug. So here I'm saying data, I'm creating a file called analysis. The reason I'm creating a file called analysis is because every time I work on a project, the final file I create, I always label it analysis so that if I can come back to this project in 6 months, in 6 years, I know exactly what file I need to look for to run my statistics. So my final file is always called analysis in every single project that I work on. So here it is, it's called analysis. The set statement calls the data set that was created here. And I only have one statement, one line of code in my data set. Total cost equals sum of RX cost, comma, hospital cost. I could have really done RX cost plus hospital cost, but if I had used the plus operator, this missing values would have created errors in my final file. So I don't want to use the plus operator. Instead, I use the sum function. I could have also written an if-then statement. I could have written an if-then statement saying if RX cost is missing, which is RX cost equals period, then really RX cost equals 0. I could have said that and then done the plus statement of the sum function, but I don't need to do that because the sum function actually accounts for the missing values pretty well on its own, and using that if statement doesn't really help me accomplish anything. So I run my code, log statement looks good, I have 14 observations. Here's my output. Now the total cost, you can see here is the sum of these 2 columns of data, and where RX cost is missing, total cost is simply equal to hospitalization cost, 5330, 5330, right? So we know this worked very well. Next, we have my analysis file. We just need to calculate means, we need to run our t-test, and we will have completed this particular homework. So I'm going to run means. In my means statement, you'll see I use the class function with gender statement written. This will make sure that we calculate means and standard deviations for males and females separately so that we can look at these numbers visually before we run the analysis. In my var statement, I actually only needed to write total cost. I did not need to write the other 2 ones, but I listed them anyway because I just wanted to see how prescription costs and hospitalization costs are distributed in this data set. All right, so here you see we have 7 females in the data set, 7 males in the final data set. Total cost is 5666.87 for females, 5997.43 for males. You can also see the breakdown for prescription costs and hospitalization costs for males and females. For example, you can see that females have only $2,600 in prescription costs, but males have $4,000. But females have $3,400 in hospitalization costs, where males actually have lower $3,100 in hospitalization costs. Numbers look good. This means I just need to run my t-test at this point. I'm using my proc t-test to run my t-test. Data equals analysis, class, gender, VAR, total cost. This actually is the same syntax as the mean statement. This is an independent samples t-test. Please don't confuse this for a paired sample t-test, which actually needs both a different data structure and some different code. All right, so let's look at our log first. Log looks good. Here are my results. You can see here that the means and standard deviation have actually been repeated. Even though we ran a proc means earlier, we didn't need to because those numbers are repeated in this output. You can see that the difference between the costs for males and females in the pooled method is $330. And this difference is not significant. And I know that from looking at the pooled value for the t-test. And I'm using the pooled value because my equality of variance test suggests that I can use that as opposed to the Sathit weight test, but that's getting into statistics and not SAS programming, so I'm going to not get too far into there. So this is the final answer. Males have that much costing in total healthcare costs, females have that much, and that difference was not significant as per a t-test. Couple of quick caveats before I wrap this up. Number one, remember again, all of these data is hypothetical. I literally sat at this computer and I made up these numbers. So these numbers are absolutely meaningless. Please don't use them anywhere. Second, if you actually want to compare costs across individuals, t-tests are not a really good way to do that. Costs are actually not normally distributed in most individuals. Costs have several zero numbers, have distribution properties that are non-normal in nature. So t-tests are not very appropriate for comparing costs. But in this particular example, when I generated my fake cost data sets, I actually did use a normal distribution. So it works okay in this particular example, but I would not recommend using t-test to compare costs in a usual data set. There are several other limitations or caveats to doing a health outcomes project where you simply calculate all cause healthcare costs from prescriptions and hospitalizations for patients with diabetes across gender using a study design like this. But please ignore those things because this particular project was not meant to reinforce aspects of study design, principles of statistical analysis. All I had intended to show from this project was what a typical health outcomes project would look like. And I've tried to set it up to be as close to an outcomes project as possible, even though several exceptions may happen because of study design issues or statistics issues. So that concludes my explanation of the homework. I want to pause now, hear from the three people on the call, and I want you all to tell me what you did, how you approached this differently, where you may have done things incorrectly, or if I did something incorrectly, please let me know, and we can go back and fix those errors as well. I'm going to open this up for discussion now.
Thank you so much, Professor. Well, I did in two different ways. One is, like you have said, like eliminating all the patient who didn't have diabetes and just summing up all the hospital costs and prescription costs. That was one method which you just rejected. The second was similar to this, but little different. What I did is, firstly, I calculated the total hospitalization cost according to Bini ID. After that, I calculated prescription costs separately, and only in final step I just merged them. And but the results were totally different 2 years. So I'm analyzing right now what I made mistake.
Shishir, because we do have some time, do you want to share your screen so we can look at what you did? And
Yeah.
you can say no. I'm not trying to point out mistakes in what you've done. I'm just hoping that the way you approach this problem can help learn all of us some lessons about health outcomes research.
Yeah, sure.
Okay,
I'm sharing right now. Yeah.
Let me give you access to share your screen. Okay, go ahead and share your screen.
Well, this is my coding.
Okay.
Firstly, I just check the eligibility first. It came out fine. Let me run that too. Previously, we had 18 rows and 2 were not eligible, so it became 16. After that, I went for second eligibility. For that, I use following coding. Please have a look. So the output would be like this. This one is sorted one. So all the Bini ID, all the Bini IDs had diabetes, so just it didn't change anything.
Can you go back to the code, Shishir? I want to see what you did there. Can you walk us through what you've done with the first and last variables?
Yeah. I just used the idea that you have taught. I will show through my output.
Okay.
This is my output. If any Beni ID has diabetes, then it will sum up for F1. Then if it do not have, then it just neglects, and if it has, then it adopts. Like
Okay.
in case of this, we have two sum because diabetes is repeated twice, and similar like that. And as for subsetting, I just output if it is greater than one. That means if there is greater than one diabetes, then just output.
Okay. Can I add a comment to that, Shishi?
Yeah, yes, sir.
I really like what you've done. This is a very creative and an effective way to identify diabetes, not at a claim level, but at a beneficiary level. So this is a great example of how to do this. One thing to be careful about when you do this is that your output data set will still have more than one row of data set per individual, right? Because if you open that final data set, you have still individuals repeating, right? Each individual can be in
Yeah,
more than one row, which is fine. You just have to be careful and aware of the fact that individual one still has three rows in this data set.
yeah.
Okay.
And for that, I have used another proc SQL to merge them.
Okay.
Yeah. This is my final hospital cost.
Okay.
I checked. It's similar to the yours result.
But there are 15 people here. Can you tell me why?
Yeah, uh, there is no six in number six in a prescription. Sorry. There is no six in eligibility. The Beni ID 6 is not valid for eligibility.
Okay.
So it will just erase out after we merge in final one.
Okay.
Second, what I did is, well, I just merge out the hospitalization cost and eligibility, first eligibility.
Perfect. Okay.
This is merge one. Okay, now it's 14 because
Perfect.
6 is cancelled out.
Yeah, I
Now
like
what we have is Beni ID, gender, these are not required, and main is hospitalization cost.
it. Okay.
Okay, up to here we are fine. Now I just merge the RX claims and NDC fed by NDC code. For that I have sorted both data, then merge them. Okay, this was the result.
Okay.
I think my main problem was in here. I just had to analyze that. Then the final merge data was administered in the proc SQL. Wherein I calculated the prescription cost for individual Beni ID.
Okay.
For now, there are 15 Beni IDs. And as for my last step, I just sorted out the first one merged and the prescription cost. And the result was Beni ID gender, rest, hospitalization cost. No, this is not the one. Okay, this was my final data set. We have hospitalization cost, prescription cost for individual Beni ID. And I also sum the hospitalization cost and prescription cost. For that, I used this one.
Okay.
And the last step was to perform the indemnity test, and the mean came up like this.
Okay, that's very interesting. uh, I think the hospitalization cost is where there probably was a problem. Can you go back?
I checked the results for hospitalization cost. It was exactly the same as yours,
Are you sure it
but
was the same for everybody?
yeah, the difference was in prescription cost. I just auto-summed all the prescription cost of all the individuals. They were quite different.
Okay. Can you scroll up to the where you calculated? Let me look at that one more time. See if I missed something.
Yeah, yeah.
Prescription costs. So
This
this is
one.
the challenge with most programming in SAS, right? The challenge with programming in SAS is not learning the syntax. The syntax is easy and it can be fast and quick to learn, but you will have errors that SAS will not tell you is an error, but the numbers are different, and we need to figure out why they are different, right? Okay, let's see that. Sort underscore RX. Kaustav, as you're looking through this, if you see something, please let me know. Can you scroll a little, Shushir?
Yeah.
Equals 1. Okay. I don't see anything here that could be an error. Can you scroll down? Maybe in the next step we'll find something.
Next step is a small thing.
Okay.
I just sorted out
Yeah,
both the data set.
70 plus 2. Okay. Shushir, can you please open the PRES underscore cost file? I want to compare it to the file that I created.
Yeah, sure.
Kaustav, do you see something?
I just had one clarification to ask
Yes,
for.
sir. Yeah.
So, yeah, go ahead.
Where differences I found were in Beni ID 7, 9,
Any
and
edit to
some others as well.
So, if we go back to the code, do we want to keep all the claims that are there in sort RX in the RX claims file, or do you want to match? Do you want to first select claims files for diabetes drugs only and then
No, we are not doing diabetes drugs only. We are doing all costs.
all drugs? Okay.
Sushil, sorry, can you please open that file one more time? I want to compare what I had versus what you had.
Okay.
5, 1, 2, 3, 7. So for 7, the cost
Yeah.
is the same.
Yes, from 7, and then there is difference in 9 too, I think.
Yeah, 9, the numbers are different. 10, the numbers are different also.
What I analyzed is that, what I found is that, let me show you one thing. In RX claims, the Beni ID was repeated 1, 2, 3, 4, 5, 6, 7 times with unique NDC codings. But in my case, it was repeated 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Huh, that's interesting.
Yeah.
Let me open. So how many times was it actually in the data set?
7 times. Also, I checked into your codings as well, but the 7 was equally repeated 9 times. So
So I had that error too. Is that what you're saying?
No, I think there is some mistake in while merging or something like that. I think
Yeah.
I could not understand that part too. How just it repeated 9 times, but in
I
the
can see the
original data set,
observation 24 and
yeah,
observation 20 and 30 are exactly the same.
Yeah.
yeah,
Now
yeah.
I understand what's happening. So this is a great point, Shashir. I'm glad you brought this up. The reason this is happening is because the NDC underscore FAD 690 file is actually not a distinct file. There is duplication in that file, right? So if you look at our can you open the RX claims file, the original file?
Yeah, sure.
I've understood why this is happening. So look at the NDC codes for individual number 7. Are there any duplications?
There is no duplication here. But I checked the original data set of which one? NDC FAD. There was repetition of following codes. This one and this one. This one and sorry, yeah, this one.
29 and 31? Yeah.
Yeah, there was repetition of these two codes in NDC FAD.
I see. Let me check.
I exported the NDC FAD in Excel format and I just sorted out and found out that there was a repetition.
Okay. Let me see what may be causing the duplication, because clearly there is duplication going on, which is incorrect. I'm running this on my end as well, so give me just a second.
Yeah, sure. Also, what I did was export all the files and did exactly same in Excel, try to mimic the process,
Yeah.
but came up with different answers there.
Okay. Yeah, this is a challenge with most SAS programs. This is why SAS programming is difficult, not because the syntax is difficult, but getting the programming flow to work correctly is where we are most likely to make errors. Let me try something. I will tell you what is happening. I think I know why this is happening. I just need to confirm that I'm correct. Give me a second. Okay, I understand why this is happening. So, Shishir, can you go to the NDC file? Can you open the original NDC file?
Yes, sure.
So if you sort by NDC code,
Let me see. Yeah.
okay, so look for 23490. Can you scroll to the bottom? Well, actually, you know what? Scrolling is going to take too much time. Why don't I share my screen and I'll show what I'm looking at?
Yeah, sure.
It's easier to show it this way. Okay. Can you see my screen?
Yeah.
Okay. So I wrote a little bit of code here. Let's see. So I wrote these 3-4 lines of code to go to my NDC file. And I found out that this NDC code for this number is in the NDC file twice.
Yeah.
Right? So because this is in there twice, even though the cost is the same, because it is in there twice, it is causing an error in terms of the merge. Because when this merge is happening, remember this is a left join, but the way the left join works is that if there is a value in here, if there is an NDC code in this file, which is found in 2 rows of this file, then there is a one-to-many merge happening. Whenever we are doing merges, we need to try and do a one-to-one merge as often as we can. One-to-many merges can be very dangerous, and that's exactly what is happening. And I didn't catch that either. So I had an error in my code. So if I simply write the word distinct before my merge statement, that will fix the problem. So if I do this now, so let's check my log. And now you'll see that this individual 7 has 1, 2, 3, 4, 5, 6, 7 rows instead of 9.
Yeah. Now it's fine. Yeah.
Right? So this is what is happening. So having that distinct can fix it. Another way to fix it, if you don't want to write the distinct statement, is to basically first take your NDC file. So I would write a proc sort. Okay. I would write a proc sort, and then I would add the no dupe function. The no dupe function in proc sort, the no dupe key function in proc sort basically removes duplicate for the key variable, which is NDC code. So if you run this no dupe key, you will see that the log basically will say that 1838 observations with duplicate key values were deleted. So if you do the deletion ahead of time and then do the merge, so now if I replace the NDC underscore FAT 695 with NDC, but I don't write my distinct statement. So you could do this in a simple data step with a merge with no distinct option. This will also identify the correct file. So let me sort by Benny ID. 1, 2, 3, 4, 5, 6, 7. So there you go. So this is a great example, Shashir. I want to go back to you sharing your screen, but thank you for showing us this error, which I did not catch either because I did not anticipate that there were duplicates in my NDC file.
Yeah. I think it will change the result as well.
Will it? Okay. Do you want me to go ahead and run the whole thing?
Yeah.
Okay. So now that we've fixed the RX costs, I want to run everything else as well. Okay. Are these the numbers you got, Shishir?
I think that I got in Excel sheet.
Did you get it in SAS?
No, in Excel.
But the numbers you just showed me were these, right? Were they not the same numbers?
No, not different. Those are different.
So what else is different between what you are doing and what I'm doing?
Because in my coding there is still repetition of 7. I haven't corrected it.
I see. Okay. So thank you for bringing that up. You helped me identify an error in my code, and kudos to you. You get extra points for doing that. Thank you. And that's another lesson to say, no matter how long you've been programming, we all make errors, and it is okay to make errors. That's why when you work on a program, you always need a second programmer to go through your code and identify errors like this.
Yeah, that I realize. Yeah.
Even the most experienced programmers will sometimes have errors in their code, and that's just the nature of SAS programming. particularly somebody like me, I'm not a programmer, right? I have never been trained in programming in languages beyond SAS. I use programming for merely running my projects and health outcomes. So in cases like this, for individuals like me, errors may happen. And we have to have individuals, other people come check the code, review and double check everything that we are looking at to make sure our results are accurate. So thank you, Shishir.
Thank you.
Does somebody else want to share what they've done or what problems that they've run into as they were working on this homework? Queenie, Ham, volunteers. I'm not going to force you and no judgment. You can see that I've made mistakes too. So if you have mistakes in your code.
I know I just mistake because I really don't understand the data. That's why I did a lot of mistake on that code.
Okay.
Yeah.
Do you want to share
Well,
what
I know what I did wrong, so I don't think so. I'm sorry.
Okay, that's fine. No pressure. You can volunteer if you want to. Queenie, how about you?
So I tried calculating the cost, thinking that maybe I'll just first merge all the data sets, create one data set which has AWP as well as the cost variable which is there in the hospitalization. I think that's the Benny visit file. So that did not happen for me. I tried and tried, and then I think I just need to run, like, calculate the cost beforehand and then merge the data set. And I was trying to not to calculate cost until I have like everything there in one file. So maybe that is where I was wrong.
Can you tell us what you struggled with when you were doing the hospitalization cost? Is that what you said you struggled with?
Yeah, so firstly, what I did was I merged RX claims in FAT 690 file by NDC code. And then what I thought was, like, then I realized that in the Benevisit file and the merger file, like the file which I just merged, there was nothing common between them. There was Bene ID, but when I merged the RX claims in FAT 690, I could see all the values missing for Bene ID.
How did that happen?
I don't know. That's like, see, that is why I was like so confused that why is that not happening? Then I tried to create one. What?
Do you want to share your screen and let us look at it?
It's not the best programming, but okay. I'll do that.
We're all here to learn.
Okay. Just a sec.
We do have 10 more minutes, so I want to take this time to share all the ways that coding can go wrong, right? And I showed one way coding can go wrong. Hopefully you can show us one other way coding.
Yeah. Can you see my screen?
Yeah.
Here. Say, oopsie, what I did. See. I have everything except Bene ID and fill date. Like, I don't need fill date and day supply, but I do need Bene ID.
Sorry, can you go back to the code?
Yeah.
So can you tell me, Queenie, what type of merge you did here?
Left.
Is that a left join? It's not. It's a full join, right? You've not said if A equals 1. And if you had said if A equals 1, that would be a left join. So now your output data set has 15,000 rows. Look how many rows it has. It has 15,777 rows. So the 30 something rows where Benny date is not missing, Benny ID is not missing, are in your data set. You just have to scroll to find them.
No, it is missing. Oh,
they're somewhere in there, but you have to scroll through 15,000 rows to find them.
Okay. Oh. Yeah.
So go back to your code, write if A equals 1. So after the by statement, output. Now
Is it-
run that code. See, so those individuals were always present in your data set. You just couldn't see them because you did a full join as opposed to a left join.
Yeah. And also, on that note, is it possible to calculate cost at the last when we have merged all the data set? Like, not calculate cost before that. Like what you did, like, you calculated total AWP before that, like before actually merging that with Benevisit.
You can, but again, the problem will be the error that I made in the code between one-to-one versus one-to-many merges. As often as possible, you should try to do one-to-one merges, right? One-to-many merges always have errors in them. So if you try to do the merge before calculating total cost, you will have a different number of rows for beneficiary one in one data set versus another data set. And if you do a merge like that, you will always end up with mistakes, errors that you sometimes don't easily identify. Instead, if you manage to make the data sets and set it up such that there is only one row for each individual, then the merge will be perfect and you will not have you are less likely to have errors.
Yeah, because in my coding, I tried that not to use the proc sequence and just use the data set, that like the data ones, but I don't think I was quite successful in that. So
yeah, so when you are doing the proc SQL without the data, you have to be careful. Sorry, when you are using data sets and not proc SQL, you have to be careful to not do to not make errors in your first dot and last dot variables. And I'm not saying that because it's sometimes easier to make errors with the retain statement than with the group by statement. But really, as you saw from my code, errors can happen from any which direction, right? So you just have to be careful when programming. Okay, is there anything else you want to share? Any other challenge you had with this code?
no.
No? Okay. Well, thank you for sharing your code. I appreciate it. Shishir, thank you as well. Hong, thanks for being here. That's all I have for today. Any other questions you want to talk about?
Professor?
Yeah.
Yeah, I think we are still mistaken.
Okay.
In case of third Bini ID, there is still repetition in original data. So if we like exclude all the repetition, it will also go out and it will again like create a problem.
Can you say that again? You think we still haven't fixed the problem, you think?
If you open the class RX claims,
okay,
original file, yeah. In the Bini ID tree, there is still repetition. The second last and third last, yeah. So what we have done is that we just erase all the repetition, so it will also go away, won't it?
Let's see, how did we fix the repetitions? No, I don't think so. Okay. So let me open the RX costs file. It should not remove those duplications. So if somebody got the same prescription 3 times, they should still be in here 3 times. So how many times was this beneficiary in there? 1, 2, 3, 4, 5, 6. Yeah, let's look here. 1, 2, 3, 4, 5, 6.
Oh, it's fine. Okay, yeah.
Yeah. So look, if you see here, the NDC code 545 is repeated thrice.
Yeah, it's fine.
The
Yeah.
85 is the same all 3 times.
Yeah, yeah.
Right.
Okay. It's just confusion. Yeah. Thank you for
Yeah.
clearing.
So yeah, I know it is confusing, but doing it this way, make sure that if somebody got the same prescription repeatedly 3 times, we still count all of those costs, right?
Yeah.
Thank you, Shishir. This has been super helpful, and we've managed to identify other ways you can make mistakes with this code. So I appreciate you putting in the extra effort in Excel and trying to figure out what happened here.
Thank you so much, sir.
Okay, that is all I have for today. So if you all don't have any more questions, let's call it a day. And next week I will upload a video about good programming practices, just to get some good habits installed in you as you begin your own programming experiences. And then we can talk about the project later that week.
Yes, sure.
Just for curiosity, has anybody started working on the project yet?
Nope, not yet.
Okay. So we might want to take 2 weeks for you. I might want to give you guys 2 weeks to work through the project because there's no hurry for us to go ahead and finish it quickly. And I want to make sure you guys have enough time to actually work through the challenges in that project. So I will communicate that over email, but this is the end of all of our SAS Bootcamp's material. So thank you all for participating so far. I hope this has been helpful. I will stay in touch with you all over the next few weeks again.
Yeah, thank you.
Thank you all. I hope you have a good day.
Okay, bye.
Bye.